Kinetic and Thermodynamic Control of Chemical Reactions. Kinetics refers to the rate of a reaction or how fast a reaction will proceed. Kinetics does not tell you how much product is being produced. Thermodynamics refers to the relative energies of the reactants and products, or the concentrations of reactants and products at equilibrium. Thermodynamics will not tell you the rate of the reaction. In the reaction shown, the pathway to produce C and D is both kinetically and thermodynamically favored. Kinetically favored because the energy needed to form C and D is lower than the energy to form E and F. Since the activation energy needed to form C and D is smaller, the rate of forming C and D is greater than E and F. The reaction is also thermodynamically favored since C and D are at lower potential energy. Thus, for most reactions, we can say that the rate of formation of the more stable products will be faster than the formation of the less stable products. This is because the more stable products follows a pathway that has a more stable lower energy transition state and will have a smaller energy barrier or activation energy. What happens to the ratio of products if the energy barrier to form the more stable products is greater than the energy barrier to form the less stable products? Look closely at this reaction and the two pathways. In this equilibrium reaction, the pathway to produce the less stable products, E and F, is kinetically favored since it has the lower activation energy. And the pathway to produce C and D is thermodynamically favored since products C and D have a lower potential energy. It is interesting that when we carry out this experiment at lower temperatures, the major products are E and F, and at higher temperatures, the major products are C and D. Why do we get these results? At lower temperatures, less molecules have enough kinetic energy to surmount the activation energy to produce C and D. Therefore, the reaction to produce E and F is preferred because it has a lower energy of activation. These conditions produce more of the thermodynamically less stable products, E and F. This reaction is said to be under kinetic control. Why is C and D produced in greater yield at higher temperatures? At higher temperatures, even though the products E and F will form at a faster rate, some molecules of A and B will also have enough kinetic energy to surmount the higher activation energy, leading to the formation of some of the more stable products, C and D. The activation energy for the reverse reaction in forming C and D is very large. Thus, once C and D are formed, they will not likely be converted back to A and B. On the other hand, the activation energy for the reverse reaction in forming E and F is not as large. Therefore, the reverse reaction will readily occur at higher temperatures. Thus, over time, at higher temperatures, equilibrium concentrations will be achieved that favor the formation of C and D. This reaction is said to be under thermodynamic control. In summary, for most reactions, we can say the rate of the formation of the more stable products will be faster than the formation of the less stable products, because the more stable products follows a pathway that has a more stable, lower energy transition state and will have a smaller activation energy. For reactions that are at equilibrium, when the activation energy of the more stable product is greater than the activation energy of the less stable product, the ratio of products will depend on the reaction conditions. Thermodynamic control. Use higher temperatures and longer reaction times to favor the formation of the more thermodynamically stable products. These are called the thermodynamic products. Kinetic control. Use lower temperatures and shorter reaction times to favor the formation of the products that follow the pathway with the lowest activation energy. These are called the kinetic products. Note, for reactions that are not at equilibrium, generally the kinetic product dominates.